Very good morning to everyone. In this lecture, EC8791 Embedded and Real-Time Systems, Department of Electronics and Communication Engineering, 7th semester. Today we are going to discuss the ARM instruction set. In previous session, we are studied the processor, ARM7 processor, and also the architecture of the ARM7 processor, how to handle the interfaces in different modules. Now, here we are going to discuss the instruction set. So, the instruction set of ARM processor, that is a embedded system design, there is a different type. We can see the types of instruction set in ARM processor. The first one is a data processing instructions, branch instructions, load store instructions, software interrupt instructions, program status, register instructions. The data processing instruction, it is some kind of instructions are needed. That is the move instructions. It is the move from the operand. The move from the operand 1 or 2, it move to the status registers or accumulator. The operand, it can be functioned to execute the values to move to the another locations. So we can see the example of move instructions. Here the move MOV, the operand 2 is a not, and move operand 2, it moves up to in status register. So the syntax, the first we can design the operations and what are the conditions are needed, and the status to read, and operand 2 to move to the location of status registers. For example, we can see the move R0, R1, it move R2. So the as 10 is a data in the R0 and R1. So the R0 and R1 is moved to the R2 register. So here the simple example of move instructions. Next we can see the arithmetic instructions. So the arithmetic instructions is logical instructions and multiplications and inversions and divisions, subtractions, etc. Now we can move to the logical instruction, that is a barrier shifter. The ARM does not have a different actual shift instructions. It has a barrier shifter which provides a mechanism to carry out the shift as part of the other instructions. The barrier shifter, it is a left shift and a right shift, and move are less than or greater than. So here the barrier shifter left shift, it is shift left by the specified amount, that is multiplied by power of 2. For example, the left shifter LSL space as 5 is equal to multiply by 32. So the carry flag register to logically shift to the destination path. And also the barrier shifter right shift, that is the logical shift right, the shift right by the specified amount of values, that is we divide by power of 2. So we can take this example, that is a LSR as 5 is equal to divide by 32 or addition by the 32. It is a logical shift right and logical shift left. It is a arithmetic shift registers. So the arithmetic shift right and arithmetic shift left, it divide or multiplied by power of 2. It is a preserve the sign bit for sign bit shifted in a 2's complement. And also the arithmetic instructions, that is add the 2-bit value of carry. Now we can see the arithmetic operations. So these are the arithmetic instruction of ARM processor. So the ADC, that is add 32-bit value and carry. So the value of RD register is equal to Rn plus N plus carry. It is a value of Rn plus N plus carry. So the 32 complete set of 32-bit value plus the carry of the value we can add to the Rn and add two 32-bit values, that is a ADD, that is RD is equal to Rn plus N. Next, the reverse subtract bit, that is a RSB. It is a reverse subtract of two 32-bit values, that is a RD is equal to N minus Rn. And also next, the reverse subtract with carry of two 32-bit values, that is RD is equal to N minus Rn minus carry flag. So the carry flag of data plus the two 32-bit value to add to the RD. Next, the SBC, that is a subtract with carry of two 32-bit value. RD is equal to Rn minus N minus carry flag. Next, the subtract two 32-bit values, that is RD is equal to Rn minus N. Next, we can see the example of add R0, R1, R2. The R0 is equal to the addition of R1 plus R2. Next, the arithmetic instruction of subtract R5, R3 and as 10. So the R5 is a register. The register you can subtract the R3 data minus 10. It's a clock frequency, clock period or value of data in the R2. Next, the reverse subtract bit R2 R5 as OXFF00 bit. It is a OXFF00 is a hexadecimal value of the data. To reverse subtract of R2, so the R2 is equal to OXFF00 minus R5. And then the logical instructions, that is a AND, OR, XOR and bit. That is the AND is a logical bitwise AND of two 32-bit values, and the logical bitwise of OR of two 32-bit values, and then ER, that is a logical exclusive OR of two 32 values, and a logical bit, it is a clear of AND to NOT. So that is RD is equal to Rn and inversion of N. So next instructions, we are going to discuss the comparison instructions. Here the comparison, that is a CMN, it is an instruction code, compare negated. So the flag set as a result of Rn plus Rn plus N. And the compare, that is a flag set as a result of Rn minus N. And then the TEQ is a test for equality of two 32-bit values. So the flag set as a result of R and N.
Then the TST is a test bit of the 32-bit value, so the flag set as a result of R, N and N. Next, the multiply instructions. MLA, it is a multiple and accumulate. So the RD register is moved to multiply the RM into RS plus RN. And also the signed multiple accumulator long, and also the signed multiply long and unsigned multiply accumulator long and unsigned multiply long. So these are the multiply instruction of the ARM processor. Next we have to move to the branch instructions. It is a path of the different registers. There is a branch. So the PC is equal to label. We can understand the label of the data to move from the accumulator or move from the another locations. And BL is a branch with link. So the PC is equal to label, IR is equal to address of next instructions after the BL. BX is a branch exchange. PC is equal to RM and OXFFF. And BLX is a branch exchange with a link. That is a PC is equal to label, T is equal to 1, and PC is equal to RM and OXFF. Now we can see the load store instructions. It is a single register transfer instructions. There is a load word into the register. That is a RD is less than or inverse of memory of 32 address, and save byte or word from a register, and load byte into a register, and save byte from a register RTRB, and also the load half word into a register and save half word into a register. So these are the data is load to the single register. Then we have to change the instructions. We are using the logical, we are using the arithmetic, we are using the bit level, we are using the barrier shifters, etc. So this lecture we are studied the ARM instruction set in embedded system design. Thank you for watching this video.